Second part of 4.1 talks about more complex situations. So we know already, and we studied in the first section, that when we're talking about right triangles, we have this little thing called SOHCAHTOA. Right? Do you remember that? SOHCAHTOA. And that helps remind us what? What does this mean? Trigonometric ratios, right. So as we took a look here, now let's see, okay, with these questions that you guys were to have done, let's just take a look at 1A really quickly. So the tan ratio, the trigonometric ratio, is actually for tan, it's TOA, that's opposite side divided by the adjacent side. So when you do this on your calculator, okay, you'd simply do 7.9 divided by 12.3, 0.6422, and it says to one decimal place, so 0.6422. Yeah, the other one's to one decimal place. And that is the trig ratio. Okay? Remember, it's just opposite over adjacent. Now this one, the angle, remember the angle is where we use the second function. So in this case, because we're dealing with tan, we use the second function of the value of the tan, of the tan theta. So in this case, this is what you should have done with your questions from yesterday. Second function tan and 0.6422. Now I think my mode is on, oh, it's on degrees, that's great. So you want your calculator to be on degrees, okay? 32.7. Did you guys get that? 32.7 for a, okay? Awesome. So these are the two answers here for 1A. So SOHCAHTOA helps to remember which sides of the triangle we divide. Okay. So for example 2, look at this one. This one's pretty tricky. We have 1, 2, looks like 3 or more right triangles that we have to consider here. So if that's the case, we kind of need to find little bits and pieces that we can, and then use those bits and pieces that we find to find other things. Okay, that's why it's more complex. There's more steps involved. So I want to ask you this. Do you guys know what this means when they say solve for QS? Do you know what that means? Sorry? Yeah?
It's like the angle of the Q to S.
Okay, the angle Q to S. Not quite. If there's only 2 letters involved, that means it's a side.
Length.
So from one point to another point. Okay, so QS is actually right here, from Q to S. You see that? That's what we're looking for. ST in red, ST would be from here to this point, S to T. You see that? Okay, and then of course we have RT. And RT, we'll do it in a third color here. RT would be this piece right here. Okay? So that's a good question. That looks really, really difficult. But in reality, what we need to do is just view it as different triangles. So what do we have? We have, this is an angle right here. 26 is this one. Right here, it's this angle, right? It's 26. And we have this side, which, if we're talking about the big triangle that this 26 is a part of, that is the opposite side, isn't it? Oh, that side's a little wonky. But we have a big 90-degree triangle. You see that? So what could I find? What could I find pretty easily from that? Well, I could find either this side or I could find this side. And of course, QS is one of the ones we want to find. So let me just redraw that triangle. So the big triangle looks like this. This is 26 degrees, and this is 12.5. And there's my right angle. You see that? So what side is this 12.5 compared to the 26? That's the what side? It's the opposite side, because you go right through the middle of this angle and you hit this side. So that's the opposite side. Awesome. Now, what is this side over here that we're trying to find out now? It is the adjacent side. That's right, because this is the hypotenuse. That's the adjacent. This is the opposite. Okay. So what trig function would include the O and the A?
Toa.
In SOHCAHTOA, it's TOA, right. So this is tan of 26. That's the angle. Okay, I'm going to zoom out because my pen is really thick now. Let's go to 100%. Okay. Okay, so we just start to find one piece at a time, and in this example, we would find this SQ side. So let's see, it looks like they do it down here. So they use tan, opposite and adjacent, and here you go. They find QS, and QS turns out to be 25.6. Okay, so that's great. We can find that. Now, if you look carefully at this, it's a little bit tricky. Like this you could set up pretty easily, right? And then remember, there's a bit of a shortcut here. You can actually just switch these two. If one is at the top on the other side of the equation, one's at the bottom, you can simply just switch them. That's just a little shortcut. So if you remember that, you see, look at, that's what happened down here. You see, they just got switched. So you could bypass these two steps of maybe confusing work and just flip them across the equal sign, top to bottom. You can just trade. Got it? We've done that before. If you can remember that, that'll save you some time. And then you simply, with your calculator, how you would do this, oops, it just shut off on me. You would simply go 12.5 divided by, and then you just go tan 26. Boom. 25.6. You see that? And that would be your length. So did you get that answer? Okay. Okay, so just to make sure you can get that. Okay, so that's one piece. That's one piece that we would have there. Now, of course, the question would go on, and they would find other pieces using that, other pieces, and find those other lengths. Why don't we do one together from scratch, okay, so that we can kind of see how this is done. So here is a triangle. It's kind of got two right triangles in it, doesn't it? So this right here is a 90-degree angle, which means that this is also a 90 degree right there. Okay? That's also 90 degrees. All right, so what is the length of x? Okay. I'm given this length is 33 from there to there, 33. But I'm not given any other angles or any other lengths of sides. So I only have one piece. I can't really solve for x directly. I have to do something else first. And if you look over on triangle 2 over here, you see that we have an angle and one of the sides. That's perfect. If you have two things, you can solve for a third thing. And what you'd want to do is you'd want to solve for this middle length here, this height, because we can use this one in the second triangle with these guys. So let's solve for this height first. So if I just redraw that triangle for you so you can maybe see that. 35 goes there. That's the right triangle. This is 19. So which side is this over here?
Oh, that's the opposite.
That is the opposite sides. Awesome. And this is the what? 19 is the adjacent. So what trig ratio are we going to use? That's right. This is going to be tan. And the angle is given, so we're going to put 35 in there, 35 degrees. And I know what that equals. It equals the opposite side, which I don't know what it is. I'm just going to put opposite there, or OPP, divided by the adjacent side. And I know what that value is, so substitute any values in that you know. That's very important. Don't put adjacent on the bottom because then you don't know what to do. Fill in the 19. Don't put the theta. Don't put an angle. Fill in the 35. Okay? That's what we got. Let's use it. So, in order to solve for opposite side now, you know what? We multiply both sides of the equation by 19 here. Just lower that a bit for you. By 19 so that we can get rid of the 19 on this side and put it over there. So now, if you notice, the opposite side length is equal to 19 times tan 35 degrees. Okay? So please make sure you can do this on your calculators, okay? Just make sure you can do that. So you simply do 19 times, and then you type in tan 35. Good idea to close the brackets always, just in case you add something after this or whatever. You want to make sure you close the brackets because we want just the tan of 35, nothing else. Okay? So I get 13.3. Does that look right? Do you guys have that? Okay. The opposite side is 13.3. And if this is 19, this could be 13. Now it's not really to scale here, because this angle is much more than 35, I can tell you right now. So sometimes you can see by the diagram that, like, oh yeah, that looks about right. And this is correct, I would say. So we're not done yet because we need to find x. We don't really care about this part. We need to find x. But now I'll draw the triangle over here. I have this triangle now that includes x here, a right angle there. And now I know this is 13.3 centimeters. And this one over here is 33. Right? So if we have those pieces now, can I solve for x? Yeah. Okay. I can solve for x. Now, am I going to use a trig ratio to solve for x? Like, do I have an angle here? I have a 90-degree angle. Do I know what this angle is or this angle?
You can't use a 90-degree angle on this?
No, you can't use a 90-degree. That's a good question, though. Could we, could you use sine of 90 or tan of 90 or cosine of 90? The problem is that, the hypotenuse then is the opposite side. And which one is the adjacent? Plus, I think is it tan of 90? Doesn't exist, right? So yeah, that's a good question. You cannot use the 90-degree angle, okay? Good question, though. I'm glad you asked that because I don't think I've actually mentioned that, so I'm sure someone was thinking that. Beautiful. So we can't use the trig functions here, but what can we use if we're given two sides of a right triangle? We want to solve for the third, yeah? Pythagorean theorem, good old Pythagoras. Okay, and that's what we'd have to do, for sure. So you go 33 squared plus 13.3 squared equals x squared, because x is the hypotenuse, so that's the one that goes on the other side. And of course, you use your calculator to figure that one out. And you know what you could do? You guys are probably ready for something like this. You could actually write x like this. If we take the square root of both sides, you know what that becomes? Square root of squared? It's just x. So you could actually just kind of maybe do a little shortcut here and type this one thing in your calculator. Might save you some time if you understand sort of how that works. So the square root, okay, of 33 squared plus 13.3 squared. Close off the brackets, usually a good idea. If it's the only thing you're typing, you don't have to, but good habit. Let's see. 35.57. Does that seem reasonable? Well, if this is 33, this one does have to be longer. It has to be longer. The hypotenuse is always the longest side. So that looks like it could be true. I think I like that. 35.6. Okay, let's write that down. Whoa, what happened there? X equals 35.6. Now, am I done, or is there anything I should add to this answer here? I should have units every time, right? Some kind of units, degrees or meters or something. So what? This is a length, and the lengths involved here are centimeters. That's correct. Okay, let's check. So that is the correct answer. Awesome. Anybody have any questions about that? No?
So it's like mathematically impossible to find tan of 90.
That's right. Tan of 90 doesn't exist. Yeah.
No matter what you do.
No matter what you do, tan of 90 is not, yeah.
So like Albert Einstein couldn't find it.
Albert Einstein couldn't even find it. That's true. Yeah,
So
it's
it doesn't exist.
it's like your homework in your bedroom when something is due. It's like you can't find it. It's impossible.
So like
Trying to divide by 0.
Right, like trying to divide by 0. Yeah, it's totally true. It's the same thing, really.
potentially it could have an answer to it.
No, it's
It
not
can.
potential. No.
Potentially.
Okay, so you want to do number 4 and number 5 right now. Okay, go. All right, so this one's a bit of a tricky one because you've got to find an angle first. I think this would be the best angle to find right here first, and I'll show you why in a minute. So we have the opposite side and we have the adjacent side. So that's going to be tan, isn't it? So tan of x here is going to equal 8 over 11. So how do we find that angle? This is where you use the second function, right? So the second function of 8 over 11 is x. That's how you get them to kind of switch places.
Like 36 of these.
About 36, did everybody else get that? 36? Point what? 36.0?
Yeah.
Okay. So if this one's 36, then what you're going to want to do from here, the easiest thing to do is to remember that all of the angles of a triangle have to add up to 180 degrees. So if you consider that big triangle, you'd have a 90 right here, and you'd have a 36 right here, and then you'd have this theta, and that all has to equal to 180. Right? Now if you solve for this thing here, you'd want to subtract these from 180. So you want to take those away, get them to the other side. So we're going to subtract 90, well, plus 36, which is what? 126, right? So minus 126. So what's 180 minus 126 is going to be 54 degrees. I think that should be your answer. Now, I think you said that you subtracted this from 90. You 90 subtract 36. Technically, okay, so because this is a right triangle, yeah, I think it would be important for you to remember that all three angles add up to 180. Because you have a right angle triangle and because 90 is half of 180, it's the same as doing 90 minus the one angle. But just in case you come across a situation where you have a triangle and one of them isn't 90 degrees, then you want to go 180 minus the two angles. Yeah.
I know that has to equal 180.
Yeah, okay, good. As long as you know it has to equal 180, that's important. Good. So here's your answer, 54. Any questions on that one?
No, hold on, wait. Oh,
Okay, so here's 36 right here, and this one is 54. And this is the one we're trying to find, so that's our answer. All right, so here is my work for number 5. Your work might not look exactly the same way, but let me try and walk you through it here. So what I noticed was that I have an angle, and I have this side for this smaller triangle. See that? This is the adjacent side, and x is the hypotenuse. So adjacent and hypotenuse are connected with the cosine function. So if I fill in everything that I'm given here with these three things, that would be cos of 28 equals, the adjacent is 6.3, and the hypotenuse is x. Okay? So if I multiply both sides by x and divide both sides by cos of 28, it's like these two switch. Remember? That's the shortcut I showed you. And so when you do this on your calculator, you should get 7.135. If you rounded that to 7.1, I'm okay with that. So x should be 7.135. That's the first thing that you should be able to find there. Question?
yes. So at 6.
Okay, so once you've gotten that far, then what you want to do is you want to take a look and say, okay, how do I find y? Well, y is part of a larger triangle. Now I don't know what this side is, but because I know x now, I know what the hypotenuse is. I know that side. It is 7.135 that I just found out, plus this little extra of 0.8. You see that? So now I have a new triangle that has a hypotenuse of 7.935. So an angle of 28, y is the opposite. And the x, well, not the x, but this side is the hypotenuse. So opposite and hypotenuse are connected by so. So sine now of 28. So you can use different trig ratios with the same angle. You're just involving different sides of the triangle. So sine of 28 equals the opposite side, which is y. I don't know what y is, so I write y, divided by the hypotenuse, which is the side that's opposite always of the 90 degree. And so that now we know is 7.935. So you bring this up and you multiply both sides by 7.935, and you get a y value right here of 3.7 or 3.725. And those are your two answers right there. Any questions about that one? All right, so no, it's not a parallelogram. Good. No, it's not. A parallelogram is opposite sides are parallel. So these ones have adjacent sides are parallel. This would be a trapezoid, though.
So what would
Okay.
that call the adjacent side of parallel?
Well, nothing really. There's no special name for this particular one.
Oh, maybe.
Okay. Sorry, these aren't parallel. These are the same length, right? These are. I think I said adjacent sides parallel. Sorry, it's not parallel. Adjacent sides. No, parallel is like this, right? They never touch. They're always the same distance apart. The two little dots there, nicks there, that means they're the same length. That's all that means. Okay. So example 3 now. A piece of plywood is cut into the shape shown. Calculate the dimensions of the plywood. Okay. So here's a real life example that if you didn't have a measuring tape and you wanted to draw this out, you could totally use trigonometry to find this. Hey, the beautiful thing. You don't have to do direct measurement with math. You can figure it out based on established rules that we already have. So with this one, what you could do is you could split this, and they show you in the solution, you could split this into a triangle and a square. So here's a square, and here's a triangle. Now, you would have to figure this out on your own on what the first steps would be. But because we could just arbitrarily, that means just kind of out of the blue, we could drop a line straight down here that would make a 90 degree. That's possible, right? Then this side and this side would all be the same length. That would be a square, because we have all these 90 degrees. Okay. I think we can assume that's 90 degree up there in the corner. Okay. So here we have this triangle now that we're talking about. And you know what? We could find, yeah, it's assumed that this is 6 feet, just same as this, and so on. All right?
That bottom be 60?
This would be 6 feet too, yeah. So look at what we have. We have an angle, we now have a right triangle, and we have an opposite side of 6. So we could find both the x and the y in two separate methods here. So if we take the sine, first of all, that's going to give us opposite over hypotenuse. So we can solve for x. So you see this? Sine of 68 equals AE, that's this side length of 6, divided by x. You could solve for x pretty easily by doing 6 divided by sine of 68 to get this number. All right? So once you get part of this, once you get this one, then you could get y either using Pythagoras, y squared plus 6 squared plus whatever that is there, 6.5 squared, or equals 6.5 squared, or you could do a trig ratio again. You could do opposite and adjacent. And what trig ratio uses opposite and adjacent?
Little one,
10.
10.
Okay. Okay. So, and then the final piece, I'll go back to the diagram. The final piece, right, once you've gotten y here, would be to add it to 6 feet to get this whole length right here. Okay? You see that? So, it's going to be your responsibility, guys, to draw the diagram, or if you're given a diagram, to mark it up, label it, split it up, try and use Pythagoras' theorem and SOHCAHTOA to try and find all the pieces, even the angles if necessary. Okay? So this is going to take some thinking, but I would really encourage you to make a sketch, and if they give you a sketch, write on your notebook there and mark it up. So I'll give you a little hint to start this one. This one says find the angle of offset between the two pipes. Okay, so the angle of offset, I guess that would be, is that the angle of offset right there? Right? So from, right here, it's labeled right here. So this is, so the pipe has to travel like this. This is the angle that we're looking for right here. Okay? And then how long is the pipe, the travel pipe? So that's from here to here. So we have a right triangle there, don't we? With some information. So find the angle using this side, which is the opposite side, and this side, which is the adjacent side. And then we'll have to use Pythagoras or another trig function to find this length of pipe. So I'll let you guys tackle that one.